You have prepped the generic Spark questions, but Databricks has its own unique, deeper layer. I just went through the full process for a senior data engineer role. In this video, I am breaking down the exact questions they asked, from the initial screen to the final system design round, including the one question that almost tripped me up. I asked about failures, but they tested for something deeper. That question about Delta Lake failures was a decoy. They do not want you to just list acid properties. They're assessing if you understand what they guarantee: reliable, concurrent writes. Can you explain the transaction log, like a ledger, enforcing atomicity? It's the engine for time travel and schema changes. That technical depth is what gets you past the screen. You are on thin ice. They ask about a slow job, but repartition and cache is a trap. It is the expected, basic answer. You must immediately pivot to diagnosing the root cause. Did you consider skew, broadcast joins, or data spill to disk? Can you read a Spark UI stage detail to pinpoint the bottleneck? That's how you prove you do not just know commands, you solve problems. Think of it like this. Spark is the raw engine and fuel. Databricks is the entire, finely tuned racing team. They expect you to articulate that critical difference. It is not just open source versus managed. It is about the integrated ecosystem, the collaborative notebooks, optimized cloud infrastructure, and Delta Lake that transforms a powerful engine into a championship-winning platform. Forget lead code. Databricks only tests these 5 hidden patterns. Now, picture a live Databricks notebook with a slow-running cell. The interviewer is watching. Your core job here isn't just to write code, it's to articulate why each optimization choice matters for distributed compute. You will diagnose partitions, explain catalyst optimizer benefits, and prove you think in terms of cluster resources, not just syntax. This moment is your strategic advantage. While others might just write asserts, you will explicitly handle CDFs _change_type field to isolate recent errors, merging them with historical baselines for trend analysis. Show them you design for observability at scale, catching data drift before it cascades. That's how you elevate a simple test into a production-grade system. Watch that watermark setting. If it's too aggressive, you are losing crucial state data and causing silent query failures. Ask them about the trade-off, late data tolerance versus resource strain. Defend your logic by simulating late-arriving records in a test cell. Prove you think in streams, not just batches. I interviewed at Databricks. Their real test wasn't the coding. Here's their litmus test. Can you defend your architectural choices for the lakehouse? You need to articulate why you'd use a bronze, silver, gold layer versus a one-size-fits-all data lake. Then, crucially, prove you know when to apply streaming versus batch in each layer. This reveals your practical depth. They're listening for this precise insight. Late-arriving data isn't a crisis, it is a guarantee. You must show how Delta Lake's time travel and ACID transactions manage this seamlessly in the silver layer. For schema evolution, you are enabling safe table modifications without costly backfills. This is how you build resilient pipelines that protect business intelligence, proving your architecture is robust, not brittle. Stop imagining cost as a trade-off with performance. You can have both. Choose Photon for immense speed, serverless for instant scale without management, and standard for ultimate custom control. This strategic selection is how you architect a lakehouse that dynamically optimizes every workload, making your entire data operation both powerful and economically intelligent. Databricks grilled me beyond coding. Their secret interview weapon is this. Think of this as an architectural challenge. You are asked to remodel a chaotic, crowded house. Their true goal is to see if you can envision the elegant, unified blueprint of a lakehouse, replacing disjointed rooms with one open, governed foundation for all data and AI workloads. That's the architectural mindset they're testing for. Now, you are in a heated technical debate. They are not grading your solution, they are watching your principles in action. Do you prioritize the customer's outcome or stubbornly defend your code? Show me you will align on core values, then logically decompose the problem. This reveals if you will build bridges or just your own ego. For a true customer-obsessed engineer, there's only one priority. It's not debugging first. You apologize, confirm the business impact, and commit to full transparency throughout the fix. You focus on restoring the service that pays their bills, not proving the elegance of your architecture. This is a test of your values under fire. Databricks does not really test Spark. Here's what doomed candidates. The leadership interview is about scale, not just results. They will drill into how you have created leverage for the entire organization. Did you design a framework others adopted? How did you change a process? Think beyond your team. This question decides if you are a multiplier who can elevate the entire platform. Your answer must show systemic influence. Failing to highlight Unity Catalog or Databricks SQL is like a master chef forgetting to mention their signature sauce and premier kitchen tools. It signals you've only been cooking basic recipes, not building a sophisticated, secure, and integrated data kitchen for the entire enterprise. They are the backbone of the modern platform. A final, critical test of your judgment isn't during the interview, but at its end. This is your moment to show strategic thinking. Ask about their toughest scaling challenge or the one process they'd rebuild from scratch. You are not just being polite, you are demonstrating you are already on the team, thinking about the hard problems they face. Databricks interviews focus heavily on their specific ecosystem, Delta Lake, Photon, and the Lakehouse paradigm. Beyond raw Spark knowledge, they test for production-grade thinking on optimization, reliability, and cost. For a deeper dive on any of these topics, check my playlist on advanced Spark and Delta Lake patterns.